This question starts with this rational function. F of x is negative 3 times x minus 5 times x plus 1 over x plus 4, x minus 2. Find the domain, find vertical asymptotes, horizontal asymptotes, slant asymptotes, x-intercepts, and y-intercepts. So let's start by looking at the domain. So we know we're not allowed to divide by 0. So x plus 4 cannot equal 0. X minus 2 cannot equal 0. So x cannot equal negative 4. X cannot equal 2. So we remove those from the possible domain. So negative 4 is removed, 2 is removed. But everything else is acceptable. Nothing else causes a problem. You just can't have division by 0. So if we list that in interval notation form, that is negative infinity to negative 4 union, negative 4 to 2 union to 2 plus infinity. Now, from there we want to look at the vertical asymptotes. Vertical asymptotes will be places that make the bottom 0 but doesn't make the top 0. So again, same kind of thing. X plus 4 is 0, x minus 2 is 0. The bottom is 0, but the top wouldn't be. So x equals negative 4 is one vertical asymptote. X equals 2 is another vertical asymptote. So let's take a look at the graph and see if that's supported by what we see on Desmos. So we have our function here. F of x is negative 3 times x minus 5 times x plus 1 divided by, on the bottom we have x plus 4 and x minus 2. So we see this, we hope we have a vertical asymptote at x equals negative 4. And it sure looks like we do. We can always adjust it here a little bit. And we want to have another asymptote at x equal 2, vertical asymptote. And again, zooming out, we can see indeed that seems to be the case. Domain, there is no value, right? If x equals negative 4, it doesn't land on the graph. Same thing if x equals 2, it doesn't land on the graph, so those are not in the domain. Now I also need horizontal asymptote. So looking at this, what can we say? Well, if we multiply all this stuff out, we would have negative 3 times x squared followed by a bunch of other things. Downstairs, we would have x squared followed by a bunch of other things. Let me show you what I mean by that. Here we have f of x is negative 3, x minus 5, x plus 1 over x plus 4, x minus 2. If I multiply out x minus 5 times x plus 1, what do I get? X minus 5 times x plus 1, x squared plus 1x minus 5x minus 5. It looks like that's x squared minus 4x minus 5. So upstairs I have f of x is negative 3 times x squared minus 4x minus 5. Downstairs, I have x plus 4x minus 2. Let's see what we have there. X plus 4, x minus 2, x squared minus 2x plus 4x minus 8 gives me x squared 4x minus 2x plus 2x minus 8. And then if we multiply this out, again, you see negative 3x squared followed by lower terms. Negative 3x squared plus 12x plus 15. Downstairs, I get x squared plus 2x minus 8. Now, how do we think about the horizontal asymptotes? If x is 1,000, 1,000 squared is 1,000,000. So 2,000 relative to 1,000,000 is negligible, minus 8 negligible. So the bottom is basically 1,000,000. Upstairs, if x is 1,000, 1,000 squared is 1,000,000. Negative 3,000,000 plus 12,000 and 15. These are basically negligible. So as x gets large, it's dominated by the highest powers. and I have negative x squared over x squared, ignoring everything else. And that gives me my horizontal asymptote of y equals negative 3. So we'll go back and we'll take a look at the graph and see if we can identify that. So this is what we had last time on Desmos. Do we see a horizontal asymptote at y equals negative 3? It looks good. Indeed, that is there. Now, slant asymptote, well, you have a slant asymptote if the degree of the top is 1 more than the degree of the bottom. The top has degree 2, the bottom has degree 2. That's what enabled me to have a horizontal asymptote if they're the same. Or if the bottom is bigger, then the horizontal asymptote would be y equals 0, but no slant asymptote here, no oblique asymptote. Because the degree of the top is not exactly 1 more than the degree of the bottom. Well, we're going to finish this off by looking at x-intercepts and y-intercepts. So we're going to focus on this part of the function one more time. F of x equals negative 3 times x minus 5, x plus 1 over x plus 4, x minus 2. The y-intercept is easier. Remember, the y-intercept occurs when x equals 0. Find y when x equals 0. So plugging in at x of 0, what is f of 0? Negative 3 times 0 minus 5 times 0 plus 1 over 0 plus 4 times 0 minus 2 gives me negative 3 times negative 5 times 1. 4 times negative 2, negative 3 times negative 5, 15 over negative 8. Just so we can see that as a decimal, that is negative 1.875. So we believe the y-intercept, the x value is 0, the y is negative 1.875. So let's jump back to the graph and see if that is the case. Where is it crossing? Where is x 0 and y is negative 1.875? And it looks pretty good. So if I zoom in on it, do we see that's where it crosses? Sure looks that way. So we feel pretty good about our y-intercept. Now let's finish off with our x-intercept. The x-intercepts will occur when the y values are 0. So we have our same function. To find the x-intercept, set y equal to 0. So I get 0 equals negative 3 times x minus 5, x plus 1, over x plus 4, x minus 2. Setting the top equal to 0, x minus 5 is 0, or x plus 1 is 0. X is 5, or x is negative 1. So then what are we going to do? Then we're going to take a quick look at our graph. What do we have? Do we see it at 5, 0? We do. And do we see it at negative 1, 0? We do. Those look like those are our intercepts.